dependent on their hinterlands for food production. And finally, they lie within ecosystems that are already stressed and therefore most at risk, and mangroves you can see listed there by the IPCC. So let me take just a handful, firstly, of the non-sea level rise climate changes, which it is my job just to bring to your attention, or more likely remind you of, because you'll be already aware of them. Many of our delta areas lie in the paths of intensive tropical cyclones: the Caribbean, southern and eastern Asia, the Bay of Bengal, the Arabian Sea, the east coast of Africa. Those traveling from Southeast Asia today will have left behind with them, they'll know, a substantial tropical cyclone that's taken the lives of about 33 people in Guangdong province, left behind it more than half a meter of rainfall on Monday and Tuesday, just earlier this week. So these are issues that confront us around the world on a daily basis. And Nobuo Mimura from Japan, who I'm grateful for this set of 3 slides, has put together graphically an issue here in this particular region. We have already low-lying land, the sine qua non, if you like, of deltas. Impose on that the area subject to here a fairly high level of sea level rise, and impose on that the 100-year return tropical cyclone mapped as a storm surge here, and we're going to see the very large areas that may be exposed to this nexus of impacts. And Mimura calculated that something like 10% of the population of Asia as a whole was exposed in this catalogue of regions. My second non-sea level rise climate change impact I want to bring to your attention is of changes in runoff. Now, the IPCC made some progress by comparing and collating about 13 model results available at that time, mapped those areas in color here where 2/3 of them agree whether they'll be drying in the browns and yellows or wetting on an annual basis. The shading indicates where it says 90%, but 11 out of the 13 models agree. The white areas where there isn't any agreement, that doesn't mean no change. From that map, you might infer that southern and eastern Asia can be expected to see substantial increases in runoff. But the story is not quite as simple as that, and indeed has some potential important consequences for us here this week. Because as early modeling, and this particular one is now some years old, for India, for the Hadley model showed, and increasingly has been some convergence of evidence from other regional models, we expect an increased intensity of rainfall reflected on the left-hand side by the reduced number of rain days for much of the subcontinent, but an increased amount of rainfall per day. But in fact, in the catchment area of northern and eastern India, the catchment of the Brahmaputra Ganges, you can see, in fact, both an increase in the number of rain days and an increase in the amount of rainfall in those rain days. So this is truly an important second climate change issue that will impact delta areas from their watersheds and then on downstream. And that enabled Nigel Arnell and other authors in the IPCC to begin to map the very large numbers that they estimated to be at risk here, as you can see, in billions, but the extent of the box there showing the uncertainty of those numbers. These are billions at risk, additionally at risk due to climate change from expected decreases in moisture availability, which I've extracted from a table and I've plotted against the IPCC temperature ranges, the SRES ranges down below, and some measures of mitigative action above. So we walk into the future hitting these numbers at different paces, and the paces are at our decision. They may be at the bottom through different development pathways, which imply different amounts of emissions and different rates of warming, and they're very high under A1 and they're low under B1, and we're probably moving along A2 at the moment. Or we can take actions specifically to do with international agreements on mitigation, shown at the top of the line, and we can walk more slowly into these numbers. Here, the metric is millions at risk. And that change in runoff has a fourth consequence, which is of altered food potential for and in these delta areas, remembering, as we should, that some of them are now homes to burgeoning megacities. The cultivable area for unirrigated agriculture is shown in greens and browns. At the top there, that's current suitability. And for one particular model, which I won't go into detail, for the 2080s, for one particular scenario, so there is a range of these, there are indications where the browns are projected decreases in arable productivity. And the point I want to make is that while there is not complete convergence from different models of this particular condition, the indications are that that increased seasonality of runoff that I described earlier will indeed have an important effect on productive potential in some of these regions, that in the non-monsoon periods, water availability may indeed be less, and this could certainly impact on productive potential in the region and of the hinterlands of the deltas as well as the deltas themselves. And fifthly, there are important, indeed I believe, measurable effects on the ecosystems of some of these delta areas. This slide lent from me from Virginia Burkitt, showing the stressed and dying marshland that is related to current freshwater drought. Now, I'm not an expert on that, but I want to use this to point out that there are these current stresses already on ecosystems. I've mentioned mangroves as well, and these indeed could be aggravated by the climate change condition. Indeed, so often what the IPCC concludes is that current stresses will tend to be aggravated by climate change stresses. And finally, in this gamut of climate change stresses additional to sea level rise, let me mention human health, here sketched qualitatively by the author team. The point I simply wish to make is their collective judgment from reading the literature is that the negative impacts outweigh the positive, and if you look at the sources or provenance of these major impacts, they are essentially those that one would expect in tropical mega cities in delta areas. Increasing vectored insect disease such as malaria or the potential for it, the risk of increased malnutrition, especially amongst the poor, if one has reduced productive potential in agriculture, increased death, disease, and injury, possibly from changes in air quality and extreme events, and an increased burden of diarrheal disease in conditions of altered water availability for sanitation. Now, all these assume a lot, or indeed make no assumptions about adaptation. They are simply the altered risk potential in a context without adaptation, but I will end, of course, by saying something about adaptation. But let me turn to that gamut also, that suite of multiple stresses coming from the condition now and in the future, even in a future without climate change, as Ericsson showed in his team's survey of 40 delta areas around the world. About 70% of those deltas are showing important signs of decreased accretion from sediment flux, mainly through increased damming and altered land use upstream, reducing the amount of sediment. That 20% show accelerated subsidence, and rates of subsidence that are really substantial. Bangkok, for example, has a rate of subsidence which, if extrapolated over a century, could exceed 3 meters. So we've got rates of subsidence that may be greater than the rates of loss of area from climate change, while only 7%, his team estimated, currently showed eustatic sea level rise. And thirdly, there is the issue of population mentioned in the early in the presentations at the first part of this morning. Almost all these deltaic areas, because they are low-lying, highly rich, soiled areas, have been attractive for human beings over long periods of time. They're characterized by dense, often farming populations. Sometimes these are concentrated in certain